this is the final video of the Squarewave Oscillator project. Is it useful? Yes, it's very useful. And does the oscillator always start? Perhaps in some cases you have to push that white button here, push button for restart, and especially on the higher frequencies, say around 15 kilohertz up to say approximately 40 kilohertz. And I've made say not oscillator, but this is of course an oscillator, but I've made a switch with which you can switch in the block wave or the sawtooth wave, and that's here in the circuit. So this is now the front. And you can say change whether you have here a needle pulse out or a sawtooth wave out. That's say the idea here. So a block wave or a sawtooth wave. At the moment we are looking at the sawtooth wave of a frequency of 123 Hertz, 122 Hertz. No problems with that. And let me switch to the higher frequencies, block wave frequencies. They are here, 1, 2, and 3, and 4. And here we are on the highest block wave that the circuit can bring. It's now on say 16 kilohertz, but there is here a frequency switch with which you can say set the frequencies. 11 kilohertz, 16 kilohertz. Is that all? No, that's surely not all, because we have here a so-called needle pulse alignment setting potentiometer, and you can use that when you switch it on here, and then we have needle pulses. And these needle pulses go higher, say they go to 29 kilohertz. And when I turn that potentiometer here, you can surely see what happens. The frequency goes down to say 23 kilohertz, and the highest frequency is say 29 kilohertz, and that is say what it all is. Output level is set here with this potentiometer, and that is this potentiometer in the circuit, 50k, 50,000 ohms, and there is a series resistor, and of course you can say in a certain way take out here DC and DC voltage, say to drive a transistor circuit or whatever. And here you have the AC voltage. It is decoupled with a capacitor of 470 nanofarad. That means that you can also say use this decoupled option. Again, to drive a transistor or to do experiments, say to test capacitors, test you can even test with this circuit coil circuits, resonance circuits. Of course, well, could be that the highest frequency that this oscillator can give also limits the possibilities of testing oscillator, coils, etc. etc. Anyway, what were the most important adaptations? And here the circuit, how it is now. This is the most recent circuit. I'm not going to publish another circuit after this video. So, take your time, take profit of this circuit. Say the only idea was, again, the new idea was here, to say in a certain way shortcut the one of the frequency capacitors in the capacitor bank. And that's here, and I've done that here with that 4K7 potentiometer that is here, 4K7 here, and here's the knob on the outside, and when you turn that knob you can make needle pulses in a certain way, needle pulses, not very sharp needle pulses by the way. Perhaps I have to make another electronic circuit for that, another setup, but anyway, you see what that means. So in a certain way you have here needle pulses in the 29 kilohertz range, and these are the needle pulses here, etc. etc. Well, let me switch the needle pulse set switch off. Let's see what happens. And we have here again directly on 16 kilohertz, quite good waveform by the way, block wave, and well, it's on 4 here, on 4 of the frequency switch. Then we are on 16 kilohertz. Let's see whether we can try this higher, get this higher. This is of course lower. It's 11 kilohertz. Good block wave by the way. And here of course the say the needle pulse only works here when we switch it on. Say let's switch it on. Now we are on the highest frequency band. Now we are on a lower frequency band. Perhaps interesting to show that you can also get needle pulses in a certain way in that lower frequency band, say 1.4 kilohertz. I switch now to lower frequencies, and let us say turn this potentiometer, the needle pulse alignment. Let's see what happens. So that's surely not dramatic, but anyway, and this is the lowest frequencies that this generator can bring, and we are now on say 90 Hertz. I again change the frequency potentiometer. We are on 59 Hertz, and again, well, in a certain way you can see that these are needle pulses even on that low frequency. And when I touch, not when I touch, but when I align here this potentiometer, so the whole idea of needle pulses works, and that's the most important thing to tell, and that's also the reason why I don't republish this circuit again, etc. etc. I switch now the needle pulse set switch off, and then we are on this frequency. 90 Hertz. Change the frequency somewhat to 120 Hertz. Very good waveform, by the way. Now I'm switching through the whole, that's important to tell, the whole 4 positions of this Squarewave Oscillator. Let's see what the scope can bring, what the scope tells us about the frequencies that are generated. So, switch now to position 2 of the mains frequency switch. We are on 546 Hertz and the waveform is very okay. Tiny flaw here is this, but anyway, 550 Hertz. Now another position of the switch. And now we are on 1 kilohertz approximately. And now to the highest frequency. The good thing is, I had not expected it, that well, it did not want to stop. And now we are on 16 kilohertz. That's quite good. Change the output level. And we see a small deterioration of the waveform. That's completely logical. But the waveform is very pure at 16 kilohertz. And well, change again the frequency switch. That's here. Let's see whether we can go to higher frequencies with this very simple 3 transistor oscillator. Well, that doesn't work. We are on 12 kilohertz. And now we are again on 16 kilohertz. But I have told that the maximum frequency is 29 kilocycles. So let me try to get to that frequency. I switch on now the needle pulse, and now we are on 23 kilohertz. I change the potentiometer of that needle pulse generator, and now we are on, say, 30 kilohertz. Well, I think that this is it all. I only have a few moments on my camera, pan over somewhat regarding the front page of this oscillator circuit. I only want to show, say, that we can make block waves, but also sawtooth waves. So this is the sawtooth wave that the circuit can make. Of course, it surely doesn't get to the 20 volt or 40 volt range, but anyway. And I've made, by the way, 2 capacitors here. They are not indicated at the moment. One is 10 nanofarad and the other one is 220 nanofarad. I have to indicate it on the front plate, but it is in the schematic and it is here. So 10 nanofarad for the higher frequencies to get the sawtooth wave, and here 220 nanofarad for the lower frequency band. And very important to tell that capacitor only works in a very limited way, say on 50 Hertz or 100 Hertz, 130 Hertz. That does not want to work properly. this capacitor anyway. This is the final video about this project. Many thanks for watching. This was all. Pen over somewhat till my camera switches off. Looks quite sloppy, but is surely not sloppy. And again, well, perhaps when I have time, sometime, this is also finally a quite important part of the circuit, where I have made the audio that you can switch on and off, and the LED light emitting diode indicator that the circuit works or not. And when it doesn't want to work, push this button here to restart the oscillator. Much more information in the earlier videos. And again, thanks for watching.